Okay, so today's video is going to be about competitive programming books and my review of Guide to Competitive Programming, this blue book that you see on the screen. So I've known about competitive programming since my first year in university, but I was way too scared to touch the subject, which was a wrong strategy. I remember I was basically looking for a magic pill and I was Googling for must-read competitive programming books. And I remember about these books, Competitive Programming by Stephen Halim, when it just came out, and it was just third edition about like 5 or 6 or 7 years ago, and I still did not read them. I put them on my shelf, like my to-do, my reading list shelf, and it's staying there since then. It's been staying there for way too long. So today I just decided to, knock these books one by one. I decided to just knock them out one by one. I'm not gonna start until I finish about 10 or 5 most recommended competitive programming books. Again, it's not going to make me better, and I probably will forget most of the stuff that I read because that's how brain works, but I still want to give it a try. I still want to just skim the books and kind of put a green check mark on these books. Kind of like satisfy my intellectual curiosity and tell myself, okay, I know what's inside those books. So having said that, I'm going to show you one little trick, and I really like these books because they introduce me to new tricks that I've never known before, like discovering something totally new. So this is a simple factorial code, right? It just calculates the factorial. And this is a trick that I found in this book, in this blue book, Guide to Competitive Programming. Look at this trick. It's so neat and so nice. Basically, you have a step of I plus 2, and then you calculate in parallel the product of 135 and 246. You calculate in parallel the product of odds and evens, and then you just multiply them. That's so sweet. I've never seen this before, and it's these epiphany moments that I like. So when I was skimming this blue book, I discovered this factorial trick. Also, another interesting thing that I learned was that in the last chapter, in chapter 15, there is like additional problems in this book, and he was basically showing the solution to a probably regional or even world finals level problem, very difficult problem. This very difficult problem, you have to think not brute force. You have to think not of data structures. You have to think sideways. You have to come up with your own totally unrelated idea, and it totally blows my mind when I see these interesting ideas. So he had to create a timetable, and he had to apply a graph on a timetable to calculate something else, and then you actually get the answer. So when I read this problem, when I read about the solution, I realize that I'm actually still going to try hardest problems for the sake of trying. I'm just curious how these problems work. I probably will never be able to solve them myself because my rating is really low, right? And I'm not really putting too much effort into it, but I still want to just kind of give it a try and see how those problems work inside, how they make those problems, those super hard problems. Well, not at the level of 3500, let's say, a level of master or international grandmaster, like level of 2600 or 3000 level problems, right? Just want to see how they work. Just want to see the solution and try to understand the solution. Even understanding the solution, I believe, is a good sort of exercise for your brain, right? But anyways, to me, these competitive programming problems, they are like tasting a wine. You don't know, but when you actually see the solution, it's like, you have a mental satisfaction, feeling of mental satisfaction, like mental boost, just exposing yourself to the solutions. Even though you can't solve, you're exposing yourself to the solutions, and you're like, wow, I never thought this is possible. I never thought it's possible to think this way. And that's why competitive programming is awesome. It's awesome because it kind of it basically expands your thinking ability, right? It shows you many different ways. Because in your production, if you're a data engineer, if you're a backend, you don't really deal with algorithmic complexity. You deal with infrastructure complexity, like how to make two different systems work together. Most of this modern software engineering, it's not about algorithmic complexity, like solving some hard algorithmic problems, unless you work in a specific company, in a specific domain, like math modeling, like some heavy computations, right? If you're doing some math heavy stuff. I mean, I'm talking about most daily software engineering jobs. They are not about algorithmic complexity. So it's just amazing that this competitive programming community exists and it teaches you. It's kind of like chess and mental sport. And yeah, it's probably too late for me to become legendary grandmaster, but I'm still gonna just read those books just because I want to put a green check mark and tell to myself, okay, I know what's inside. I finished reading this book. I finished reading that book. So yeah, I'm probably gonna read top 5 or top 10 must-read competitive programming books, and I'm gonna kind of like offset my disappointment that I did not start earlier. Let's put it this way. So yeah, some of these books are really old, like this one, Programming Challenges. This book was first released in 2003 when I was just a teenager in school. So yeah, this book it's just like, I think it's just worth reading the book itself, just to put a green check marks again, like I said. Cracking the Coding Interview, I remember I started this back in 2015, never finished it. Still gonna finish it because it's one of those must-read books, like recommended books. And I actually changed my attitude. I realized that these books themselves, they're not gonna make me better. The only way to improve is to obviously practice a lot. Practice a lot, like solve freaking 1,000 or 2,000 problems until you get really good. But anyways, that's probably all I wanted to say. And yeah, I'm gonna continue knocking out these books one by one. Yeah, you know about this book, Introduction to Algorithms. This is like the Bible of algorithms, right? It's by Corman. I even have a paper. I think I even have a paper cover. So yeah, there is lots of math problems, math textbooks that I actually want to read as well. But like this book, for example, Competitive Programming in Python. Because I'm a Python programmer, this immediately catches my attention, and I can't just pass by this book without reading it, right? I can't just pass by, because I feel like since I'm a Python developer and since I am kind of like into competitive programming, I still want to just read the book. I know I probably will not apply most of the stuff from this book, but I still want to read this book. And because the title is so catchy, the title screams to me that I have to read it. And yeah, there is lots of interesting books that I want to read. I probably will forget most of the stuff, but I still recommend even skimming certain parts or chapters of the book. Anyways, I'm gonna start with another most recommended book, Competitive Programming by Stephen Halim. He actually, like, his latest 4th edition has become so big that they divided it into 2 books. So they have like 2 books, book 1 and book 2. I'm gonna post next review when I finish this one. Thank you.